Okay, so for part D, it says that instead of pulling out 2 socks, you pull out 4. So I have sock 1, sock 2, sock 3, and sock 4. So I pull out 4 socks. Okay. Well, let's say that this first, okay, my bad. The question says, what is the probability of the event of getting at least 2 socks of the same color? Okay, well, let's say that when I pull this first sock out, it's blue. And let's say I pull the second sock out, and it's white. And let's say I pull the third sock out, and it's gray. Okay, what's the probability that at least 2 of these socks are going to be the same color? Well, think about it. There's 3 colors of socks. And if you already pulled out a blue, a white, or a gray, then this 4th sock must repeat a color. It must be another blue, or it must be another white, or it must be another gray, because we only have 3 colors to deal with. So if you pull out blue, white, and gray, then the 4th has to repeat itself. Or let's say you pulled out a gray and a blue and a blue and a white. The probability that I'm going to repeat a color is 100%. It's always going to happen, because no matter what your first 3 socks are, your 4th is always going to repeat. So either it'll repeat early on like this, gray, blue, blue, white, or if you have all 3 different colors, it'll for sure repeat on the 4th. Or let's say you have gray, gray. Well, that's a repeat right there. Anyway, the point is, if you're pulling out 4 socks and you only have 3 colors, one of those socks is definitely going to have to repeat a color, because there's only 3 colors and 4 socks. Okay, let's keep going. It says a penny, a nickel, a dime, and a quarter are tossed. What is the probability of obtaining at least 3 tails on the tosses? Okay, well, first let's figure out what this at least 3 means. It means 3 or more. So 3, 4, 5, 6. These are all numbers that are 3 or more. Okay, but it says, what is the probability of obtaining at least 3 tails on the tosses? And we're going to say tails is a T. Okay, let's see how many things we tossed up in the air. We tossed up a penny, a nickel, a dime, and a quarter. So 4 things were tossed. So that means we're going to multiply 4 things together. Kind of like if I had 3 children, I'd multiply 3 probabilities together. If I pulled 2 socks, I'd multiply 2 socks probabilities together. We tossed 4 things, so we're going to multiply 4 things together. Okay, now it says, what is the probability of obtaining at least 3 tails on the tosses? Well, if I only have 4 coins, I can't toss 7 heads. If I only have 4 coins, I can't get 6 tails. If I only have 4 coins, I can't get 5 heads. So technically 3 or more tails only means 3 or 4, because we only tossed 4 things. Okay, so first we need to figure out the possibilities. Okay, to figure out the total possibilities, I know I put this chart right here, but we don't really need this chart. But to find the total possibilities, we're kind of going to think of these two boxes multiplied together, these four boxes multiplied together. Okay, so we got 4 multiplied together. Okay, let's think about this. How many possibilities are there on a penny? If we're talking about 3 tails tossed, whatever. Okay, so on a penny, you either have a heads or a tails. There's only 2 possibilities that you could see. On a nickel, you only have a heads or a tails. On a dime, you only have a heads or a tails. On a quarter, you only have a heads or a tails. Okay, so the total possible combinations that we could have is whatever 2 times 2 times 2 times 2 is, which is, I think, 16. Okay, this is going to be my denominator. So instead of drawing one of these wicked tree diagrams, we're just going to take kind of a shortcut. So I don't want to draw a tree diagram with 4 sets of these branches, so I'm not going to. Okay, anyway, so to figure out all the possibilities, since we're tossing 4 coins, we multiply something 4 times, and since there's only a heads or a tails that we could have, that's only 2 things, so that's why I put 2 in there. Okay, so my denominator is definitely going to be a 16. Now let's figure out at least 3 tails. Okay, so for example, if I toss all heads, is that at least 3 tails? No, that's not what we want to find. So we want to find, out of these 16 possibilities, how many of those have 3 tails? Okay, well, that means they have to have 3 tails. Okay, what could the 4th be? It could be a heads, because those are the only combinations. Okay, so 3 tails, here's an example, or the T's and the H could be rearranged, like T, T, H, T, or T, H, T, T, or H, T, 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 T. Yeah, okay. So all of these have 3 tails. Okay. What about 4 tails? How many possibilities would that be? Well, if I'm tossing a coin and I have 4 tails, that means T, 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 T. Okay. So these are all the possibilities of having 3 tails or more, or at least 3 tails. Okay. How many is this total? From these 4, from the 3 tails, and this 1. That makes 4 plus 1 equals 5. That's going to be our numerator. So the question was, what's the probability of getting at least 3 tails on the tosses? Okay, well, 5 out of 16. This is a shortcut for how to do it. Woo! Let's use this same shortcut over here for this roulette wheel, instead of drawing a tree diagram, because I'm not going to draw a tree diagram with 36 branches. Okay, so this says a roulette wheel has 38 slots around the rim. Okay, so that means there's 38 total. Then it says 36 slots are numbered from 1 to 36. Half of these are red and the other half are black. The remaining 2 slots are numbered 0 and 00, and those are green. As the roulette wheel is spun in one direction, a small ivory ball is rolled along the rim in the opposite direction. The ball has an equally likely chance of falling into one of the 38 slots. Find the probabilities of the events in blah blah blah. Okay, well, first, how many total slots are on the roulette wheel? It says a roulette wheel has 38 slots. Okay, then it says the ones that are numbered are 36 total. Okay, then it says for the red, it says half of those 36 are red. So 36 divided by 2 is 18. So we have 18 red numbers. Then it says the other half are black. So the black is 18 also. Then it says the green are that 0, 0, and 00, and there's just 2. Okay, let's figure this out. It says find the probability of a ball landing in a red spot. So you do the part over the total. As in, the total number of slots are 38. How many of those are red? 18. 18 over 38. And then we can probably reduce by maybe dividing by 2. And you get 9 over 19. And then you cannot reduce again. Okay, let's go to the next one. It says ball lands on a 27. So let's do the 27. Okay, how many total slots are there? There's 38. And how many 27s are there? Well, there's numbers that are 1 through 36, but out of those 36, how many of them are the 27? There's only one. Yeah. Okay, now how many 00s are there? Well, there's only one out of 38. Okay, and remember when we were doing that tree diagram hoopla, that very first page of notes, it says add probabilities of different outcomes together. So these are different outcomes. The outcome for 27, the outcome for 00. Now we're going to add their probabilities together. And when you add probabilities, you add the top, and the bottoms must be kept the same. So we have 2 over 38. I think you can divide by 2, and it makes 1 over 19. Huzzah! Again, let's look at this sucker. A ball does not land on a number from 29 to 30. Okay, well, how many total slots are there? 38 on a roulette wheel. Okay, it does not land on a number 29 through 30. Okay, what are the numbers 29 through 30? 29, 30. That's 2. Okay, well, how many total numbers are there? 36. Okay, now if you say not including that 29 and 30, how many are there? Just 34. So there's 38 total slots, but it's asking about how many times we land on something that's not 29 through 30, and it has to be a number. So 29 through 30, that's 2 numbers. There's 36 total numbers. If I don't include those 2, it's just 34. So my probability is 34 over 38. Then I think you can divide by 2 probably. And we should get 17 over 19. Okay, again, it says ball lands on an even number or on a green slot. Okay, well, the bottom is our total, 38. And how many of our numbers are even? Well, we have 36 numbers, and half of those are even. So what's half of 36? 18. Whoa. Because numbers are either even or odd. So, even number is, there's 18 of those. Okay, then it says, or a green slot. Well, how many greens are there? 2. Out of how many total? 38. Okay, now we're going to add the tops and keep the bottom. So we get 20 over 38. Then reduce by 2 maybe and get 10 over 19. Woo! Okay, last sucker. It says use graph paper to design a dartboard such that the probability of hitting a certain part of the board is 3 over 5. Okay, I'm just going to show you how to make this. Okay, it says the probability is 3 over 5. So that 3 over 5, the 3 is going to be how far right you go. So on my picture, I'm going to go right 3, 1, 2, 3, and draw an up and down line. Yeah, at the 3. The bottom number is how far up you go. So that says 5, so I'm going to go up 5. 1, 2, 3, 4. And hey, you're going to pick the picture that looks like a rectangle is 3 to the right, up 5. So this part A, 3 to the right, 1, 2, 3. That means part of my rectangle is supposed to be going up and down. This doesn't have that. So A's out. Part B, 1, 2. That looks pretty good. 3 to the right. Part C, 1, 2, 3, 4. What the heck is all this? I don't even know what that is. Okay, that's not cool. Okay, 3 to the right. This last one. Hey, that looks pretty good. Okay, now let's figure the 5 up. So part B, if I went 5 up, I'd be up here, and this is the rectangle I would make. Because you have to go 3 right, 5 up. But that's not answer choice B. That's the D. If you look at the D, it looks like this rectangle is 3 to the right and 5 high. Yay!